Section 6.3 is on the operations of functions and something called the composition of functions. First, I want to go through just simple operations with functions. And we have addition, subtraction, multiplication, and division. So these shouldn't be too difficult because you've really been doing these in the past sections without even knowing it. But this little chart right here just says that if we have two functions, and we're going to call them f and g, if we add or subtract or multiply or divide them, we're going to get a new function, and we're just going to call it h. So if we were to add, subtract, multiply, or divide, we would get a new function on all of these by doing that. So let's do a specific example. If I have these two functions, f of x and g of x, my first operations I want to do is I want to add them. So I want to add 2x to the half plus a negative 6x to the half. Now, just like anything else, just because there's fractions in the exponent, don't let that freak you out. If you had x squared plus x to the third, I would hope you say you cannot add those because they don't have the same exponent. Same thing here. Even though it's a fraction, if it's not the same fraction, you cannot add or subtract it. But here we're okay because they both have the power of a half. So we're good to go. We can add these. So all we have to do is do 2 plus a negative 6 or 2 minus 6. So we get negative 4x to the half power. And you're done. The second one, we're going to subtract f of x minus g of x. So we have 2x to the half minus this entire thing. Now it's important to keep your parentheses, especially with subtraction, because when our functions get larger, we have to make sure to distribute our negative through. Here it's not a big deal because our function's pretty small, but still the parentheses are important. So we have the same exponent, so we can subtract, and all we have to do is 2 minus a negative 6, or 2 plus 6, so we get 8x to the half. Pretty simple, we're just adding like terms, basically. The next one is multiplication. So if we multiply f of x times g of x, we have 2x to the half times a negative 6x to the half. Now I hope you remember what you do with exponents when you're multiplying. And I hope you say, oh, you add the exponents. Yes, you are correct, you add the exponents. So we multiply negative 6 times the 2, we get negative 12x, and if we add a half and half, you get 1. So we have an exponent of 1, and we don't really need to write that there. If you want to, go for it, but that's your answer. And the last one, we're going to divide f of x, so our f of x is on top, divided by g of x. Now we can see here that we have an x to the half on both the top and the bottom, so really they're just going to cancel out. Also, if you remember, the rule is when you divide polynomials, you subtract the exponent. So if we did a half minus a half, obviously we would get 0. So again, they just cancel out, and you're left with 2 over negative 6, and that reduces to a negative 1/3. So that is your answer. So those are operations with functions. Now let's actually talk about the composition of two functions. The composition of two functions is just one function inside of another function. So if we had the function f and g again, and we wanted to compose g within x, what we're doing is we're plugging the function g inside the function of x. And this reads, if I was to say this out loud, it would say f of g of x, because it's f with the parentheses is of, so f of g of x. And f of g of x is not the same as g of f of x. These are not the same. And we're going to see that in the example below when we do this. So to compose two functions, let's first find f of g of x. So what you're going to do is if I'm plugging g into f, wherever I see an x, I'm going to put this entire function. So if I start writing f of x, I'm just going to start writing f of x, so it's 3, and the next thing I would write would be x, but instead of writing x, I'm going to write this entire function. So I'm going to put, instead of x, 2x minus 1. And then it's very important to make sure I finish f of x. I did 3x, and instead of x I put 2x minus 1, but I still have minus 1 on the end. And now I'm done. That's f of g of x. Now if I simplify, I distribute my 3 through, so 6x minus 3 minus 1, 6x minus 4. This is f of g of x. Now if we flip that around and do g of f of x, now wherever I see an x in the g of x function, I'm going to put f of x. So if I start writing g of x is 2x minus 1. I have 2, and instead of the x, I'm going to write f of x. So instead of x, I'm going to write 3x minus 1. So I have 2 times 3x minus 1. And now finish the g of x. So I had 2x minus 1, so I have minus 1 on the end. So if I go ahead and distribute this through, I have 6x minus 2 minus 1, get 6x minus 3. Now I just said that f of g of x and g of f of x are not the same, and you can see right here, if we flip-flop those around, they're not the same. I'm going to write a problem down that I want you to try on your own and bring the answer to class. I want you to let f of x equal 3x plus 2 and g of x to equal negative x squared. And I want you to find f of g of x and g of f of x. Now when you do this, be careful because there is this negative right here. So when you plug in for x, make sure you use parentheses because you're going to have to distribute that negative. So I want you to do that on your own and bring an answer to class.